In the questions of probability, there is an important thing which should be always taken care of. And I have found that most of the students do not take care of that thing, and ignoring that thing may give you wrong answer also. To understand that thing, take this example. Suppose this is the building Burj Khalifa, and suppose a person jumps from the top of this building, and I want to find the probability that he will die. It is 100% that he will die. But if you do mathematically in this way, here sample space contains two elements. First, and second case, and I want to find the probability that he will die. Then probability of E, if we find mathematically, is 1 by 2, because favorable number of cases 1, total number of cases 2, answer is coming to be 0.5, that is 1 by 2. But practically the probability is 1. Why we are getting wrong answer mathematically? This is the point which should be always taken care of. And what is the mistake in it? You must take care of it. You must be clear about it. Actually, the formula of favorable number of cases upon total number of cases is applicable only when all the sample points of sample space have equal probability of happening. Here we are getting a wrong answer because of the reason that in this case sample space there are two elements and both are not equally probable. Therefore, we are getting wrong answer. That is why in this question also the statement where each element is equally likely to occur is written. In this question it is given that let mod x denote the number of elements in a set X. Let S equal to the set containing elements 1, 2, 3, 4, 5, 6 be a sample space where each element is equally likely to occur. If A and B are independent events associated with S, then the number of ordered pairs AB such that 1 is less than equal to mod B less than mod A equals dash. That is, you have to find how many ordered pairs AB are there which satisfy this condition also. Further, A and B are independent also. And if I want A and B to be independent, it means I require PA intersection B is equal to PA into PB. Suppose mod A is equal to alpha, mod B equal to beta, and mod of A intersection B is equal to gamma. And it is clear that mod of S is 6. Therefore, P A intersection B will have the value gamma by 6. P A will have the value alpha by 6. P B will have the value beta by 6. Because if I want this condition to be satisfied, it means I require gamma by 6 is equal to alpha by 6 into beta by 6. means I require alpha beta is equal to 6 gamma. Further, I will do this question in 3 ways. I will start putting the value of alpha and get the value of beta and gamma which satisfy this condition. Or I start with the value of beta and get the value of alpha and gamma which satisfy this condition. Or I start taking the value of gamma and get the value of alpha beta which satisfy this condition. All are nearly equally good, but for making your concepts more strong, further I will do the question in 3 ways. First case, I start taking the value of alpha and get the value of beta and gamma such that this condition is satisfied. First solution. In first solution, I'll start with the values of gamma and get the value of alpha and beta so that this condition is also satisfied and these conditions are also satisfied. If I take gamma equal to 1, it means the set A and B have one common element. And in this case, this condition says alpha beta is equal to 6. And alpha beta equal to 6 means either alpha is 6, beta equal to 1, or alpha is 3, beta equal to 2. And the number of ways in which the set A and B can be made in this case is 6C. 6 is the number of ways in which the set A can be made because A contains 6 elements, and number of common elements is also 1. Therefore, for making the set B, I will choose any one element of these 6 elements, that is 6C1. That is the answer is 6. And in this case, number of ways in which the set A and B can be made is, first I will choose 3 elements for making the set A. This I can do in 6C3 number of ways. And beta equal to 2 means I want B should contain 2 elements. And because one element is required to be common, therefore for making the set B, I will choose one element from these 3 elements which are in A. That I can do in 3C1 number of ways. And one other element of the set B should be from remaining 3 elements which are not in A. This also can be done in 3C1 number of ways. And the value of this becomes 180. So far I have got 6 cases and then 180 cases. And for gamma equal to 1, only these 2 cases are possible. Let us check the second case when gamma is, if gamma equal to 2, then this condition will say that alpha beta must be 12. And alpha into beta equal to 12 is possible only if alpha is 6, beta is 2, or alpha is 4, beta equal to 3. Note that alpha is always more than beta. And in this case, number of ways in which the set A and B can be made is 6C6 is the number of ways in which the set A can be made. And because I want the set B should contain 2 elements and both the elements must be already in A because gamma is 2, and because there are 6 elements in A, for making the set B, I will choose any 2 elements from these 6 elements, that is 6C2. That is the answer is 15. this. And now for gamma equal to, this was also possible. In this case, the set A should contain 4 elements, set B should contain 3 elements, and 2 elements must be common. Therefore, the number of ways in which the set A can be made is 6C4 into, and because B contains 3 elements, out of which 2 elements are common between A and B, therefore for making the set B, I'll be choosing 2 elements from these 4 elements, that is 4C2, and 1 element should be from those 2 elements which are not in A. Note that A is containing 4 elements. Therefore, number of ways in which the set B can be made is 4C2 into 2C1. Let me tell you once again, for making the set B, I require B should contain 3 elements, out of which 2 elements must be common. Therefore, I choose 2 elements from the 4 elements which are in A. Therefore, this I can do in 4C2 number of ways. And for making the set B, remaining 1 element of the set B should be from those 2 elements which are not in A. Therefore, for third element of the set B can be chosen in 2C1 number of ways. Therefore, this is equal to 15 into 6 into 2. That is again 180. And now take the case of gamma equal to 3. Then alpha beta equal to 6 gamma will mean alpha beta equal to 18. And alpha beta equal to 18 is possible only if alpha is 6 and beta is 3. That is, A contains 6 elements, B contains 3 elements, and those 3 elements should be from the elements of A, because 3 elements are common between A and B. Therefore, the number of ways in which the set A and B can be made is 6. Is the number of ways in which the set A can be made, and from the 6 elements of the set I will choose any 3 elements. This I can do in 6C3 number of ways, and this is equal to 20. Now take the case of gamma equal to 4. In this case, alpha beta equal to 6 gamma will mean alpha beta equal to 24. And alpha beta equal to 24 is possible only if alpha is 6 and beta is 4. And therefore, for making the set A, I will choose any. For making the set A, I will be choosing all the elements. Therefore, 6C6 is the number of ways in which the set A can be made, into 6C4 is the number of ways in which the set B can be made. These 6 elements are all from the set A, because I want beta also 4, gamma also 4. That is, this is equal to 15. And take the case when gamma is 5. Then alpha beta equal to 6 gamma will means alpha beta equal to 30. And this is possible only if alpha is 6 and beta is 5. That is, A contains 6 elements, B contains 5 elements, and all the 5 elements are common also. Therefore, the number of ways in which the set A and B can be made will be 6C6 into 6C5, that is 6. And note that gamma equal to 6 is not possible because beta is less than alpha. Therefore, 6 elements cannot be common. Hence, all the cases are over. In this case, 6. In gamma equal to 4, 15 cases were there. For gamma equal to 3, 20 cases were there. For gamma equal to 2, 15 and 180 cases were there. For gamma equal to 1, 6 and 180 cases were there. Hence, total number of cases we have got are 6 plus 180. I am writing here 6 plus 180 plus 15 plus 180 plus 20 plus 15 plus 6. 20 plus 15 plus 6. This is equal to 422. Now I will take the values of beta and find the corresponding value of alpha and gamma such that all the conditions are satisfied. All the conditions means this condition, and this condition are satisfied. Suppose I take the value of beta as 1, then this will mean that alpha is equal to 6 gamma, and this is possible only if gamma is 1 and alpha is 6, because gamma cannot be more than 1. And in this case, number of ways in which the set A and B can be made is 6C6, because B contains only one element and that must be common element also. Therefore, I'll be choosing any one element out of the 6 elements of the set A. That I can do in 6C, one number of ways, that is 6. And second case, if beta is 2, then alpha beta equal to 6 gamma will mean that 2 alpha is equal to 6 gamma, that is alpha is equal to 3 gamma. And now the possibilities are, if gamma is 1, alpha is 3 and beta is 2, or gamma is 2, alpha is 6 and beta is 2. Only 2 possibilities. And because this means A contains 3 elements, B contains 2 elements, and 1 element is common. Hence, the number of ways in which set A and B can be made is 6C3. This is the number of ways in which the set A can be made. And for making the set B, I want to have 2 elements, and out of the 2 elements, 1 element must be common, that is, 1 element of set B must be from these 3 elements, that is 3C1, and 1 element of set B should be from remaining 3 elements which are not in A, that also can be chosen in 3C1 number of ways. This is equal to 180. And the case when beta is 2, gamma is 2, alpha is 6, in that case, number of ways in which the set A and B can be made is 6C6 is the number of ways in which the set A will be made. And for making the set B, I want to have 2 elements and both the elements must be common. Therefore, the 2 elements of set B will be chosen from the 6 elements of set A, that is 6C2, that is I get 15. Now take the case when beta is 3, then alpha beta equal to 6 gamma will mean 3 alpha is equal to 6 gamma, that is alpha is equal to 2 gamma. I can't choose a value of gamma as 1 because alpha cannot be 2. I start with gamma equal to 2. If gamma equal to 2, then alpha will become 4 and beta is 3. And gamma equal to 3 is also possible because in that case alpha will become 6, beta is 3. Here beta is 3, here also beta is 3. In this case, number of ways in which the set A and B can be made is, for making the set A, I will be choosing 4 elements from the 6 elements. For making the set B, I want to have 3 elements, out of which 2 elements are common. Therefore, 2 elements of the set B should be from these 4 elements of set A. That I can do in 4C2 number of ways. And remaining 1 element of set B should be from 2 elements which are not in A. That I can do in 2C1 number of ways. That is, I get 180. And now when beta is 3, gamma is 3, alpha is 6. And because alpha is 6, number of ways in which the set A can be made will become 6C6. And because beta is 3 and all the 3 elements must be common because gamma is 3, therefore for making the set B, the 3 elements must be from the 6 elements of the set A. This I can do in 6C3 number of ways, and 6C3 is 20. If I take beta equal to 4, then alpha beta equal to 6 gamma will mean 4 alpha equal to, that is 2 alpha equal to 3 gamma. And in this case, obviously gamma must be even number. If I take gamma equal to 2, then alpha will become 3, which is not possible because beta is 4. Hence, rejecting this case, I take the value of gamma as 4. Then alpha will become 6. That is, the set A should be containing 6 elements, the set B should be containing 4 elements, and all the 4 elements must be common between A and B. Therefore, the number of ways in which the set A can be made is 6C6. And for making the set B, I want to have 4 elements and all the 4 elements must be common. Therefore, from these 6 elements of set A, I choose any 4 elements, 6C4, that is 15. Now, if beta is 5, then alpha beta is equal to 6 gamma, means 5 alpha is equal to 6 gamma. And this is possible only when alpha is 6 and gamma is 5. And in this case, number of ways in which the set A and B can be made is 6C6 into 6C5. 6C6 is the number of ways in which the set A can be made, and because for set B I should be having 5 elements and all the 5 elements must be common also, there were 6C6, and from these 6 elements I choose any 5 elements for the set B. This is equal to 6. And beta equal to 6 is not possible because beta is less than alpha. Therefore, total number of cases I have got are 6 plus this 180 plus 15 plus 180 plus 20 plus 15 plus 6. 180 plus 20 plus 15 plus 6. This is equal to 422. Now the third solution. In this solution, I'll be taking the value of alpha and find the value of beta and gamma such that this condition is satisfied, and also 1 less than equal to beta less than alpha and gamma less than equal to beta are also satisfied. It's clear that the value of alpha cannot be 1. Therefore, I start taking the values of alpha from 2. If alpha is 2, then this will mean that 2 beta equal to 6 gamma, that is beta equal to 3 gamma. And it is also not possible because the minimum value of gamma is 1. In that case, beta will become 3, which is not possible. Take the next case when alpha is 3. And now alpha equal to 3 means from here I get beta equal to 2 gamma. And beta equal to 2 gamma means gamma equal to 1 and beta equal to 2. Gamma equal to 2 is not possible because gamma equal to 2 will mean beta is 4, which is not possible. Therefore, for alpha 3, gamma is 1 and beta is 2. Therefore, the number of ways in which the set A and B can be made is 6C3 into, and for making the set B, I want to have 2 elements in set B, out of which 1 element must be common. Therefore, 1 element must be from the 3 elements of the set A that I can choose in 3C1 number of ways. And 1 element of set B should be from the 3 elements which are not in A, that also I can choose in 3C1 number of ways. That is, it becomes 180. And take the case when alpha is 4. In that case, alpha beta equal to 6 gamma will mean 4 beta equal to 6 gamma. That is 2 beta equal to 3 gamma. And it is clear that gamma will have to be even number. And if I take gamma equal to 2, beta will become 3 and alpha is 4. Gamma equal to 4 is not possible because in that case beta will become 6. And for alpha 4, beta 3, gamma 2, number of ways in which the set A and B can be made are, for making the set A, I will choose any 4 elements from 6 elements. And for making the set B, I want to have 3 elements, out of which 2 elements must be from the 4 elements of the set A that I can choose in 4C2 number of ways. And 1 element of set B should be from the elements which are not in A, and because there are 2 elements which are not in A and I want to choose any 1 element out of them, therefore 2C1 is the number of ways in which 1 element can be chosen from the 2 elements which are not in A. This is equal to 180. And next case, suppose alpha is 5. Then alpha beta equal to 6 gamma will mean 5 beta equal to 6 gamma. And this is possible only if gamma is 5 and beta is 6, but that is not allowed because alpha is 5. Therefore, rejecting this case, if alpha is 6, then this condition will mean 6 beta equal to 6 gamma, that is beta equal to gamma. And in this case, many cases will come. Alpha equal to 6, beta equal to gamma equal to 1, alpha equal to 6, beta equal to gamma equal to 2, and so on up to alpha equal to 6, beta equal to gamma equal to 5. For this case, number of ways in which the set A and B can be made is 6C6, because this is the number of ways in which the set A will be made, and because I want B to contain one element that should be common element, that is, that element should come from the set A. Therefore, for making the set B, I can make in 6C1 number of ways, that is 6C1. For alpha equal to 6, beta and gamma equal to 2 means 6 into 6C2, because two elements of the set B should be from the 6 elements of the set A, that is 6C2. And lastly, 6C6 into 6C5, that is 6C5. Hence, in alpha equal to 6, number of ways in which the set A and B can be made is sum of all these, that is 6C1 plus 6C2 up to 6C5. This is equal to 2 to the power 6 minus 2, that is 62. Hence, total number of ways in which the set A and B can be made is 62 plus 180 plus 180. Therefore, total number of ways becomes 180 plus 180 plus 62, that is 422.